Hello, everybody. Dan Davis, editor-in-chief of the Fabricator magazine. Thanks for joining us today. We have a really timely webinar, Accelerate Your Productivity on Projects that Require Manual Processes with Laser-Guided Assembly. More shops are looking to add value-added offerings for their customer base. Assembly is definitely one of those areas as people are trying to bring in people, in all honesty, with not a lot of metal fabricating skills. Assembly can be very challenging, and I think this webinar will cover a very useful tool to help people understand what needs to be done and get them up to speed and productive faster than they might otherwise. In general, some people just simply can't see 3D, such as your friendly neighborhood trade journalist right here, and having tools to help people feel productive, make them feel more part of the team, it's a win-win. So some matters of this webinar. Please keep in mind, if you have a question, use the Q&A box down below. The organizers of this webcast will see that, and we'll address those questions toward the end. If you have any maybe questions about technical difficulties, please use the chat function. We can all see that, and we'll try to respond as best we can right away. Also, the content of this webinar will be available after this has concluded today. You can find it on thefabricator.com. Simply do a search of the webinar title, and it should direct you right to it. So down to business. Today, Sean Francoz of Virtek Vision will be handling the presentation today. Shawn has more than 15 years experience in product management and new product development. He holds an MBA and a mechanical engineering degree. He's been with Vertec Product Management for 10 years now, and looking forward to hearing what he has to say. So Shawn, I'll let you take it away.
Well, Dan, thank you very much. Myself and Vertec team members are excited to be here. So first of all, I'd just like to say thank you to all of you for attending today and taking the time to join us. We really appreciate the opportunity to share information about our technology. We hope that you find it valuable. For myself, I've been working for Vertec, delivering laser projection tools for 10 years now. I'm pleased to report that we've helped customers across a broad range of industries build their products more efficiently and with higher quality. Before we dive too far into the PowerPoint, the presentation here, I'd like to review with you what I plan to cover. I'll start by telling you a little bit about Vertec. I think it's important that you know who we are. Then I'll go into a bit of detail on how Vertec's laser systems work, so you can gain a clear understanding of the process. And finally, I'll wrap up with some examples of how others have used Vertec solutions and the impact it's had on their business. Well, Vertec has been around for quite some time. We were founded 35 years ago by a team from the University of Waterloo. Waterloo is Canada's top engineering school. And since that time, Vertec has been a leader in laser projection, with dozens of registered patents and a steady pace of new product innovations. Vertec has continued to lead globally, not only through innovation, but also by providing industry-leading support with team members located throughout North America and in Europe and in Asia. Support is always close at hand. And Vertec has a full range of service offerings, from free technical support to professional services on demand to support contracts that can be tailored to your requirements. We've deployed over 17,000 lasers, which companies around the globe rely on daily to guide their assembly tasks. Vertec serves a wide range of industries. Our customers use lasers to guide many different assembly and inspection tasks. Companies in ornamental metals use our 2D system to guide fixture placement and component positioning for handrails and other welded assemblies. Our 3D systems are used to create composite panels for commercial, recreational, military aircraft. In fact, 23 out of the 25 largest aerospace companies are using Vertec technology. Even 8 out of 10 Formula One teams are using Vertec laser systems for composite layout. Our advanced 3D systems are also used to fabricate large weldments, such as mining equipment. Vertec lasers are even used to guide jigging and component placement for residential wood trusses. Vertec lasers are also used for paint masking and decal placement on airplanes, helicopters, trucks, you name it. So wherever manual measurement and physical templates have been causing slow production rates, operator mistakes, quality issues, Vertec has found a way to replace the old methods with laser projection. And Vertec offers solutions that fit. We have different solutions to max the complexity of the parts being assembled with a price point that makes sense. Simpler 2D applications like handrail, for example, use our product called Vertec LTG, together with our LPS-10 lasers, which you see pictured here. More sophisticated 3-dimensional applications like frame assembly use Vertec Iris 3D with our VPS-1 vision-enabled laser projector. And you can see here it has a stereo vision system integrated into the projector. Let me dive in a little bit to those two solutions. Let's start by taking a closer look at our LTG, solution for 2D applications. I'm going to run a little video here and start and stop to explain. It's very simple. It's a basic user interface. You see on the left a list of DXF CAD files. Simply click on the DXF to open it. And then on the lower left in the yellow box, you see you can select a laser to project different features of the application. In this case, the first set is projecting the outline of the fixture, the outline to allow the placement of fixtures on the table. So quickly and easily, you can see that we're projecting the shape of the rail, allowing the operator or fabricator to position fixtures quickly and easily. Next, we can project the center lines, which will give you quick and easy access to position the components of the railing. You can see this fella's really fast. That's our technician, Patrick, and he's lightning quick. Let's also take a look at our next feature, which is Iris 3D. It's a similar process with Iris 3D, but instead of simple 2D CAD, we support full 3-dimensional CAD, and it's visualized right within the Iris 3D user interface. Going through a similar process of positioning fixtures first, we can start by highlighting the location of the fixture directly on the table. Simply click the feature to enable the projection. And in this case, you can see which hole to place the fixture in, and then position the fixture and select the top to get that accurate positioning of exactly where the fixture belongs. You can step through each of the fixtures on the table for any given part until all of the fixtures are exactly in position. With the fixtures quickly positioned and you know they're in the right place and it's the right fixture, it's time to get building your part. Simply click on the components to project each component and position it in place for tack welding. Really easy to use. Once the components are in place, the primary components, it's time to move on to the accessories, things like mounting brackets, studs, bushings, you name it, those can be positioned as well. Again, as you see in the video, simply click on the surface with the component and project it in place. You can see here, clicking on the top of a bushing, it projects right away, and you can position that component for tack welding. Really straightforward. Clearly, speeding the time reducing the extra effort. Things like interpreting the drawings, measuring using tape, marking, all of that goes away with the use of laser projection. So we covered the process, I think, pretty well in those videos, the ones we've just reviewed. So I'm not going to repeat the process here, but there's a few extra things that I would like to point out. As mentioned, fabricators have the choice of following a predefined process for fabrication, or can select features using pick and project. So what you saw in the videos that I've just demonstrated was that pick and project feature. The fabricator looks at the 3D model, says, I want to assemble this bracket, clicks on the bracket to light up the projection, and then goes to work. Alternatively, we can support a pre-designed, pre-authored workflow. Typically, a predefined process would be used for more complex assemblies and for batch jobs with repeat work, whereas the pick and project process would be used for simpler assemblies or one-off parts, or even to provide extra information where a predefined workflow already exists. Important to understand that one laser typically covers an area of roughly 12 feet by 12 feet or 4 by 4 meters, although it could easily cover a larger area, as large as up to 20 by 20 with our standard range projector. These projectors, we could have one projector cover a 12 by 12 area. But if we have a really large area, say a table that's 12 by 40, we can string together multiple projectors all in the same system, projecting in concert, if you will, to cover that larger area. In addition, projectors might be fixed mounted over a work cell, or they could be mounted to mobile stands to provide a flexible work cell configuration. Importantly, the Vertec team has application specialists available. They help define the optimal solution for each customer work cell. I think it's important to back up a little bit. Now that you have a good sense of how the system works, I think it's important to understand what is the accuracy that can be achieved here. And how does the system align to the table and the part to make sure that that accuracy is maintained? Well, it begins with the CAD data. As I've indicated, Vertec LTG relies on two-dimensional DXF CAD data with height offsets from the table, whereas our Vertec Iris 3D uses CAD, which is positioned on the table within the model, as you saw in the video just played. Lasers measure the position of the table using retroreflective targets in predefined locations. For this to work, the lasers have to have line of sight to those retroreflective locations, the targets. It's okay to block a few, but only a few can be blocked. The majority have to be visible with that line of sight to the laser. The result is that for well-calibrated targets, the system is accurate to about 15 thousandths of an inch, or 0.4 of a millimeter. Of course, the accuracy relies on an accurate understanding of the target locations. It's important to understand that Vertex systems complete this alignment automatically as soon as a work order is opened. Under normal circumstances, the operator never has to intervene with the system. Their focus, the focus of the fabricator, simply is to get to work with the task at hand, marking and tacking the components. Let's take a minute and talk about how these systems have impacted some businesses in North America. Here's one, EC Fence and Ironworks, and I'll read the quote from the owner to you. The Virtek Vision projector was a complete game changer for us. It not only cut layout times and fabrication times, it eliminated fabrication mistakes. From layout railings, stair stringers, radiuses, etc., the welder fabricator now becomes mistake-free. All fabricators suffer from finding the layout guy. Vertec is the answer. Vertec doubled our production by cutting out our layup time and paid for itself in 2 to 3 times in the first year. Small investment for great returns. It's important to note that this system is a fairly new system with this customer of ours. They've been using it for about 2 years and continue to have great results. This is an interesting application. This customer has been using our systems for about 10 years and they have multiple systems deployed. Here's what they had to say. Before Iris, our inspectors used to spend a lot of time double and triple checking parts. Now, the company performs random checks, but no full line inspections. Since we started using it, we haven't had one location reject. We've improved efficiency 20 to 60%, depending on size and complexity of the part. It's been 100% accurate. So I hope that it's pretty clear now that our systems help to address the skills gap by making it easier to correctly identify part geometry and component locations. Vertec Iris 3D and LTG reduce the time for fixturing, layout, marking, and component positioning. As well, with the direct connection to CAD, deployment of design changes is faster and easier. With laser accuracy, errors and rework are all but eliminated. And with all of these features, the payback period is typically less than 1 year. Oh, okay. One more important message I do want to deliver, and that is a special shout out to some folks, Sigmund Weld Tables and BTH Sales in Ontario. They've helped us to create the videos that I shared with you a few moments ago and provided facilities and equipment to complete these demonstrations. So if you're interested in a weld table, these are the guys to contact in Canada. Please reach out using the information you see here. If you're interested in Vertec or our solutions, we have folks, again, spread around the globe, in Europe, in Asia, and in North America, ready to speak to you and answer any questions that you might have. So please don't hesitate. Contact us through the web, email, social media, or contacting one of these folks directly. So with that, I'd like to open up to any questions that you might have. Andrea, have any questions come through?
Hi, Sean. Yes, thank you very much. We do have a couple of questions, actually. One question really relating, Sean, to really volume, I guess, on the table, which is, can this cover 30 feet long beams to assemble plates and connectors? So obviously you showed both solutions today, kind of our 2D application as well as our 3D. So if you could help answer that question on coverage, that would be great.
Sure. So no problem to cover a length of 30 feet. It would typically require more than one projector.
Okay, perfect. The next question is the system a fixed system or can it be moved from weld bay to weld bay or table to table? Basically, can it be moved around the part, I guess?
Yeah, great question. I did mention that earlier in the presentation, but I'm really glad that you asked. I think we have two sort of common setups, and I would say they're probably 70-30% wise. 70 would be fixed mounted above work cells, and 30 would be mounted on mobile stands. Each laser projector does have some connected wiring. It uses a power and a communications cable between the main system and the laser. But we often have them on rolling mounted stands that can vary in height from 2.5 meters or 10 feet all the way up to 25 feet variable stand height. So very common to want to have that flexibility to move the projectors around and reconfigure the work cell, because sometimes if your parts vary dramatically in geometry, having that mobility gives you the line of sight you need to assemble the parts.
Perfect. Thanks, Sean. The next one was also to do with, basically integrating with their existing weld tables. So that's obviously a yes. You had mentioned that. I guess a secondary part to that question would be, how we showed the specific table that actually had machined holes in it. Are you able to do the same process with a fixture table?
Sure. So our system, I think, do you mean maybe like a homemade table or something of that nature, where
Correct.
maybe
Custom-made
even
table.
some welding bunks or something similar? Yes, we do have systems deployed on tables like that. As I mentioned earlier, the important part is that we have those accurately located retroreflective targets. That's what gives our system the understanding of the table and the part geometry, and the ability to locate with accuracy. So no problem to work with different shapes and configurations of table, so long as we understand those target locations.
Okay, perfect. And we answered the coverage. Oh, well, I guess maybe you can just be a little bit more specific, Sean. What is the typical offset distance from the table? And with that distance, what's the coverage area? Again, just to highlight that, please.
Yeah, great question. Great question. So first of all, it's important to understand that the laser projectors essentially have a beam output that is like a pyramid. So the further away you are from the table, the larger the area of coverage. So that's why that offset plays an important role in how large an area you can cover. I think typically lasers are offset from the welding surface or table surface in the range of 12 to 15 feet. We do have some applications where we are much further. And in fact, we even have specialized laser projector models that we call long range. They can be offset at distances as far away as 60 feet, if you can imagine that, to cover a very large area. Again, typical is 12 to 15 feet, but we can, in special circumstances, go for very long distances.
Okay, perfect. Thanks, Sean. And another one here is, does the system have the ability to show tolerances in the projection?
Iris 3D has the ability, one thing that I didn't really speak about in the presentation, but I'm glad you've asked that question, because it's an important feature. We have the ability to present text information right on the work surface. So if there's added information such as a part number, a tolerance, a weld indication of the type of weld, any of that information can be added and projected directly on the table during the work activity. And that can add a lot of value. And again, improve that fabrication efficiency, which is the big goal here.
Okay, perfect. And I think just this last question here, are 3D models of the weld fixturing necessary, or can it work with models of the parts only?
Oh, great question. Yeah. It's important that the targets, or the target/table and the part be in a common coordinate system. Other than that, that's all that's required. If you're not interested in positioning the fixtures, that is entirely optional. Entirely optional. Of course, the real goal is not to assemble fixtures, but to assemble parts. If it's efficient or fixtures aren't required, then absolutely, there's no need to include them in the CAD model and try to project those positions. Simply project the part components.
Okay, perfect. And I will take this last question here because it is definitely of importance. So having to do with the operators or assistants or the welder fabricator actually using the system, are there any safety requirements? Should they be worried about, you know, the lasers, and should they be worried about the laser class? How does Vertec deal with safety in their lasers?
Yeah, oh, I'm glad that question came up. Great question. Vertec has actually made a very substantial investment in making sure that our lasers have the brightest output possible while maintaining laser safety class 3R. Laser safety class 3R means that it's very, very low risk to operators. It ensures that you do not require laser safety glasses. You do not require a laser safety officer on site. Basically, no special safety measures are required. And the simple human blink reflex is enough to protect your eyes from any potential danger. And we have, as I suggested just a moment ago, invested quite a lot of money in research and development to make sure that we are the most visible lasers while at the same time being absolutely safe within laser class 3R.
Perfect. Well, thanks, Shawn, and thank you everybody for those questions. That definitely added a lot of value. So hopefully your questions were answered. So Shawn, that's it for questions. So I'll hand it back over to you.
Well, I guess we'll wrap it there, but I want to say a very special thank you to everyone. We really appreciate you taking the time to join us and learn about our solutions. And we definitely hope to hear from you soon. Have a great day, everyone.